Hello, my name is Nazeer from the Faculty of Civil Engineering Technology, and I will be presenting to you the graphing of the quadratic function. Now, we all know that the quadratic function has a power that is x squared, or to the highest power of square. We also know that it graphs as a parabola. Okay? This parabola opens upwards and this one opens downwards. Now, when that x squared term is positive, the parabola opens upwards. When it is negative, it opens downwards. And these 2 points, the x-intercept, are called the roots of the parabola, or the solution sometimes referred to. And when we take a look at that, the coordinate of those points, we will see that any time that you have a point on the x-axis, it will have a y value of 0. So in this case, because we're away from the origin, on the left-hand side, the x value would be minus, and the y value would be 0. If the y value is not 0, then it's not on the x-axis. It's not an x-intercept. Likewise, on the other side, we have a plus x value and 0. Now, if we have a y-intercept, like this particular point here, again, it will have a y value, and the x would be 0, because if the x was anything but 0, that point would be off of the y-axis. So you have to have that concept in mind whenever you have a point on one of the axes, x or y, the opposite will be 0. The opposite value will be 0. You have a point on x, you'll have an x value, the y will be 0. You have a point on y, the y will have a value, the x will be 0. Okay, now let's speak about the maximum point. The maximum point happens to be the vertex. It is the furthest point up or down. And when we go to the negative side, or the lower point, the lower number, we call that a minimum. So when we look at this particular equation, it opens up, so it'll have a minimum as the vertex. When we look at the other scenario, we have this opening downwards, and it will have a maximum. So these vertex, this one is a minimum, this one is a maximum. Let's go and look at some other stuff. When we look at this particular example here, the parabola opens upward, it has a square term, and the difference between the last slide and this one is that this particular parabola does not cross the x-axis, does not cross it. So this does not have any roots or solution to it, and when we factor this, the equation for this, it will give us an imaginary number. Now we know that an imaginary number is the even root of a negative number. It's the even root of a negative number. There are no solution for this scenario or this scenario here. Okay? Once you have a y value that's positive for the vertex, and that parabola opens upwards, there's no solution. When you have a y value for the vertex that is negative, and that parabola opens downward, there is no solution or no roots to that, and therefore these will not have a solution. They're called extraneous roots. Okay, let's move on again. We are going to plot the quadratic function, and then therefore we're going to need some points to plot. The first point that we're going to go after, it is the coordinate of the vertex. We want to know the extreme point. The second point is going to be the root where it intercepts the x-axis. So we want to know those points, if there's any. And we're going to go after the y-intercept, and we're going to look at the line of symmetry and symmetrical points. Okay? And it all sounds kind of complicated, but it really isn't. When we look at getting the x value for the coordinate of the vertex, it's given by this formula here. The x value, so there's an x and y value in a coordinate set. This is just the x1 for that. it's minus b over 2a. Now this formula, it's not common, but this one down here, the quadratic formula, everyone should know that. Now if you were to take out the root sign or the radical from there, you end up exactly with this. So this is one way of remembering this coordinate formula. Okay, so we are going for the coordinate of the vertex, and this would be the x value. Once we have the x value, we could substitute it back into the equation and get the y value for the coordinate set of the vertex. Let's go to an example. We have an equation that's given here. We have an x square value that's negative, so we know that this is opening downwards. Let's go and pick out our a, b's, and c so that we could use our vertex formula to get our x value. When I look at this, this is our formula that we're going to use. My b term is 1. It becomes minus 1 because of the formula, divided by 2 times a. A happens to be minus 1. So really what I'm having here is minus 1 divided by minus 2. A negative divided by a negative will give you a positive. So we really have 1/2. Positive 1/2. Now that is the x value of the vertex right there, of the coordinate set. We're going to have to take this value and plug it back into the original equation and get the y value. And that's what's done right here. I've taken, for the square term, 1/2 squared with the minus out front, plus the x value is 1/2 again. I'm plugging this in for the x, plus 6. So when we square 1/2, it becomes 1/4. So it's minus 1/4 plus 1/2 will give you plus 1/4. So this would become 6 1/4. When you write it as proper fraction, you'll have 6 4s 24 plus 1 is 25 over 4 right there. And that is the second part of the coordinate set of the vertex. That is the y value right there. Now when you have these coordinate set, if you want to check them, just plug them back into these here. You plug for the y, you're going to plug 25 over 4, and for the x you're going to plug 1/2, and you should come out with equal sides of the equal sign. Let's go and now get the roots of this particular equation, which is the x-intercepts. We're going to have the two options really. There's more than 2 options, but we're going to just concentrate. We're going to factor it, or we're going to use the quadratic formula. In this particular case, this particular equation is factorable, but I don't like the minus sign out there. You could factor it right like this, but I am particular in that way. I'm going to multiply the whole equation by -1, and it changes all the signs. And then I factor it. So for that, it'll be x and x. For 6, so that I could get 1 in the middle, it'll be 2 and 3 are the factors. I have to put the right signs where they belong, and I factor it. The next thing that I'm going to do is take each one of these factors and equal to 0. Set it equal to 0. And then you solve for x. So if I were to take this to the other side, it'll become -2. So I have one of the 2 coordinate set. We know that this is going to land on the x-axis, so the y value will be 0. And that is what is down here. Okay, the coordinate set, I placed the 0 in there. The second one here, x minus 3 is equal to 0. I solved that here. Took the 3 over there, it becomes +3. So then we have 3 and 0 as the coordinate. So we have gotten the vertex, we have gotten the root. Let's go and find the y-intercept. Okay, when we look at the y-intercept, whether it's up or down, does make a difference. You know that the x value has to be 0 if it's an intercept in the y. So if we were to plug 0 in for x in this equation, you could see you're going to be left with +6. So we know that 0 is the x value and 6 is the y value. You don't have to go and plug this in. you could have the equation in general form, meaning that you have descending power, and that c term there is your y value. Okay, so that's a nice easy way to deal with it. Again, if it's on the y-axis, the x value will be 0, because if it's anything else but 0, then it won't be on the y-axis. Okay, so we have 3 points. We also know from the equation itself that this parabola will open downwards because of the minus sign. We have the vertex, we have the roots, and we have the y-intercept. Let's go and plot this up. We have the two roots, they're plotted up. We have the y-intercept, and we have the vertex. Another thing that we should consider, and we know that this parabola, if we plotted these points, we know it opens downward. The plotting would tell you that anyhow. If we want a symmetrical point to this y-intercept, because we have symmetrical points here, we should know that the line of symmetry goes through the vertex. Okay, it cuts that parabola in two equal halves, mirror image, but two equal halves. And as a result, the distance from the line of symmetry to this point and to this point is the same. Let's go and take a look. It's really varying in the x direction. It's not, these y values for these 2 points are going to be exactly the same. And you can see y is 0 and y is 0. So it'll be what the variation is in the x direction. Now we're going from the line of symmetry, which has an x value of 1/2, and we are going to -2. So that really I have a distance in here of 2.5. Let's see if that distance over here is 2.5. We have 1/2, and we're going to 3, so that's 2.5. So this line cuts in the x direction directly in half between these two. Now if we wanted a symmetrical point on this side of this line of symmetry, what would that point be? Again, I would have to just go and look at my x value. I'm going to go and look at my x value. X is 0 here. I look at the x value, 1/2. If I wanted to put in a point over here, I'm going to add 1/2 to this value here. It becomes 1, and 25/4 would be my next point there. Okay, so anytime that you have a point on one side of the line of symmetry and you want the other one, you just get the distance to the line of symmetry and put it on the other side. Put the point on the other side. You work out. Usually you would graph this and then work out the symmetrical points. Okay, let's go to example 2. We have an equation here. We want to go and plot it up. We're going to go and get all the points necessary to plot them up, but I'm not going to plot them. You could deal with that. I'm going to go and get my vertex equation for the x value of the vertex, and we have the a, b, and c. I need minus b, which becomes plus 8, divided by 2 times a. So we have 2 as our x value of the coordinate of the vertex. Let's go and plug that back into the original equation, which is this, and I've done that right here. I plug the x value into there, and then work out the y value. So when I look at this, we have 4 times 2 is 8, minus 16 will give you minus 8, plus 6 will give you minus 2, and that's what this is. So we have 2 for the x, minus 2 for the y. We have our vertex. Let's go and get our roots. The roots are by factoring, and of course when we look at the original equation, the only factors of 2x squared would be 2x and x. When we look at the factors of 6, that when added together, when you add these inner and outer term, it'll give you your middle term. And of course you will get 8x. So this has to be 2 and 3. This tells you that the signs are the same in both of these factors, and this one tells you that they're going to be both minus. Okay, let's go and set these to 0. If I were to set this factor to 0, I will end up with x is equal to 1. 2 over 2 will give you 1 right there. And if I set this one equal to 0, just take over the minus 3 becomes plus 3, and I could write them as their coordinate set 1 and 0. So that means that this is on the x-axis, and the y is 0. And this is on the x-axis, and the y is 0. So we have 1 and 3 on the x-axis, that this parabola will be cutting that x-axis, or the intercept. When we look at this also, we could see that the square term is positive, so we know that the parabola is opening upwards. Let's go and get our y-intercept. Again, I'm going to take the shortcut. If I substitute 0 for x in here, this term cancels out, this one cancels out, I'm left with 6, so I know that my y-intercept is going to be 0 and 6. Now I have all the points necessary to plot this, and I could put down my line of symmetry and get my symmetrical point for the y-intercept also, like I explained just a little bit ago. Let's go and do the last example, and this one is factoring with the quadratic equation, so it's important that you pay attention to this one. We have the original equation, a, b's, and c's, and we're going to go for our coordinate, or our value, or x value for the coordinate of the vertex. And when I plug this into the equation, we know that this becomes a minus 1 divided by 2 times minus 2. A minus divided by a minus will give you a plus 1 over 4. Plug that back into the original equation, which is done here, which becomes 1/8 and times minus 2, and then we have 1/4. When you work that out, you'll get a minus 5. So what we have, x value of 1/4 and a y value of minus 5 for the vertex, the coordinate of the vertex. Let's go and factor it. I know that this is not factorable, so I'm going to try the quadratic formula, and the quadratic formula is right here. It is minus b plus or minus the root of b squared minus 4ac all over 2a. I'm going to plug in my a, b's, and c. Again, we have a minus in front of this. So when I go to b, I have to put a minus in front of that, plus or minus. 1 squared will just be 1. And we have minus 4 times a, which is minus 2, and c, which is minus 5, divided by 2 times a, which is minus 2. When I work out the inside of the radical sign, I get minus 39. Now that's a problem. That's a problem. When you have a minus number under an even root, when I say even root, I mean the index here, 2, 4, 6. If you punch this into your calculator, you will find that your calculator will act very funny or irrational with you. It will give you some crazy large number, or give you an error or something like that. It's trying to tell you that this is an imaginary number. Okay? It's an imaginary number, and therefore that indicates that this particular equation does not have any roots. Okay? Now we could have probably tell that from the, let me go back here, from the coordinate of the vertex. The vertex has a y value, the coordinate of minus 5, and this equation is saying it's opening downwards. So if you go to minus 5 and open downwards, you're not going to cross the x-axis. So, you know, it's trying to tell you here, hey, this is not going to have any real roots. It's going to have erroneous roots. Okay, it doesn't have any roots. So we are already looking at the imaginary numbers, what it means. When we look at the vertex right here, this thing opens downwards. It never crosses the x-axis, so it's not going to have any roots. So don't be confused when that happens, if it does happen. These are the numbers that we are going to plot. X is going to be okay, we're trying to find the y-intercept. The y-intercept is going to be minus 0 and minus 5, but if we want to substitute 0 in there, we'll work it out that way too. Okay. Points that needs to be plotted. The vertex, the roots are extraneous, it doesn't exist. And of course we have our x or y-intercept, it opens downwards. Those are all you need. That's all I have for you. I hope that this presentation helps you with your plotting of quadratic functions, and good luck.